Welcome to this deep dive. Today we're tackling something huge, something so basic it feels weird to even question it. Time. You know, that feeling of it always moving forward one second after another, like Confucius watching the river. Well, what if that fundamental sense we have is, well, fundamentally wrong according to modern physics?
That's exactly the territory we're stepping into. Our intuitive grasp of time might be, let's say, profoundly challenged by fields like quantum gravity. We're diving deep into Carlo Rovelli's incredible book, The Order of Time, and we've also got some really helpful insights from theoretical physicist Li Jianlong to guide us.
Yeah, Rovelli's a big name in loop quantum gravity, and Li Jianlong works in similar areas, both trying to bridge that gap between quantum mechanics and general relativity. And what they're finding has these massive implications for how we understand reality, especially time.
So our mission for you today is to unpack these, frankly, mind-bending ideas. We'll explore what physics tells us about time, what it doesn't seem to say, and why maybe, just maybe, understanding time means understanding ourselves better.
All right, prepare to question that clock on the wall. Let's dive in.
Okay, first big hurdle. The idea of a universal now. That feeling we all share the same present moment everywhere all at once. It feels completely real, doesn't it?
Totally. It's how we operate.
Yeah.
Like if I'm right here next to you, our now seems identical. I see you
So-
move, it feels instantaneous.
Almost instantaneous. But almost is doing a lot of work there. Even side by side, there's a tiny, tiny delay. Light speed, sound speed. It's not zero. Nanoseconds maybe, but not zero.
Okay, fair enough. Negligible up close, but scale it up, like the sources mentioned.
Yeah.
If I'm in New York, you're in Beijing, we're talking, what, milliseconds delay on a call? My now when I speak isn't quite your now when you hear it.
Exactly. And then think cosmically. Proxima Centauri b 4 light years away. If I send you a signal, it takes 4 years. You'd see me as I was 4 years ago.
So while I'm seeing you way from 4 years in your past, you, the real you, are 4 years older. But aren't we still existing in the same cosmic now?
Yeah.
I gut feeling says
Right.
yes.
But Einstein's relativity says, well, no. Flat out no. Space and time, they're tangled together as space-time. Our everyday now ignores the space part, ignores the distance. It assumes instant connection across the universe, and relativity, based on the light speed limit, says that's impossible.
Right, because information can't travel instantly. So simultaneous events across vast distances,
Yeah.
that's just not a thing the universe allows.
Precisely. There's no single objective universe-wide now. How far your now even stretches depends entirely on how precise you need to be. Nanosecond precision. Your now is just a few meters wide. Millisecond. Maybe thousands of kilometers. Beyond that, the concept just falls apart.
Rovelli has that great analogy, doesn't he, about the rainbow?
Yeah, the rainbow touching the forest.
You see it, it looks like it's right there, but you can never actually walk up and touch that exact spot. It moves with you. He says now is like that, a kind of blurry human feeling based on our local experience, not a hard feature of the cosmos.
It's a really effective way to put it. And it doesn't stop there. Relativity doesn't just get rid of a universal now. It also says time doesn't flow at the same rate everywhere.
Oh, wait, what? So not only is there no shared now, but my watch could tick differently from yours, or differently from one on a mountain.
That's exactly it. The old physics assumed one clock for the universe. But Einstein's general relativity, the gravity part, show there isn't just one time. There are essentially countless times, different for different points in space-time.
And this isn't just theory, right? The
Pre-
sources mentioned actual measurements.
Oh, yeah. Super precise atomic clocks show it clearly. Time literally runs a tiny bit slower at sea level than it does up high, like on Mount Everest.
Why? Is it the gravity?
It's the gravity. Closer to Earth, gravity's stronger, space-time gets warped more, and time slows down relative to somewhere with weaker gravity, like a mountaintop.
Wow, so altitude actually changes time's flow.
It does, and it matters. Think about GPS satellites. They're way up there, weaker gravity, plus they're moving fast, both affect their time relative to us down here.
Ah, so the clocks on the satellites are running at a different speed compared to clocks on the ground.
Yep. And if the system didn't constantly correct for those tiny differences predicted perfectly by relativity, your GPS would be useless pretty quickly. It's real-world proof that time is relative.
Okay, mine's slightly blown already. No universal now, time flows differently depending on gravity and speed. But what about the arrow? Past to future. That feels utterly undeniable. Broken glasses don't unbreak.
That's the next big twist. Because, weirdly enough, the fundamental laws of physics, the equations themselves, often don't seem to care about the direction of time. They're largely time reversal invariant,
Time reversal invariant, meaning...
meaning the math works just as well forwards as backwards. Li Jianlong uses the planet orbit example. Know its position and speed now. Physics tells you its future. But use the exact same laws, just flip the time direction, and they tell you its past just as accurately.
So the equations don't have a built-in future sign.
Nope. As Rovelli puts it, it's like a secret hidden in the equations. Fundamentally, time might not have a direction.
Okay, hold on. If the basic laws don't see an arrow, why is my experience screaming arrow? Aging, memory, spilled coffee, it all goes one way.
And that's where heat comes in, thermodynamics. Specifically, the second law. That law describes processes that definitely seem one way. Heat flows from hot to cold, not the other way around easily.
Right, irreversible processes, like friction. The bouncing ball example in the source nailed this. A ball rolling smoothly, could be forwards or backwards video, hard to tell.
But a ball rolling and stopping due to friction, you instantly know it's playing forwards, because friction creates heat, disperses energy, and that process, governed by the second law, feels irreversible. It gives you the direction.
So our sense of time's arrow is tied to things getting messier, heat spreading out.
Essentially, yes. Which leads us straight to entropy, the measure of disorder, or energy dispersal. The second law basically says entropy tends to increase in a closed system. And the hypothesis, shared by many physicists like Li Jianlong, is that maybe our feeling of time passing is the same thing as entropy increasing. Two perspectives on one phenomenon.
Wow. So time's direction isn't cosmic, it's thermodynamic, tied to increasing messiness. But that still feels pretty fundamental. Entropy does increase, right?
But here's Rovelli's most radical step. He asks, what if order and disorder aren't objective facts about the universe but depend on our perspective? If the direction of time is tied to increasing entropy disorder and disorder is subjective,
then maybe the increase of entropy isn't objective either, and therefore, objective time doesn't exist.
Whoa, how can disorder be subjective? My desk looks objectively messy sometimes.
He uses the poker card analogy. 4 cards, red, red, black, black. Looks ordered by color, right? Shuffle them. Red, black, looks disordered by color. Order to disorder.
Okay, makes sense visually.
What if you ignore color and look at the numbers? Say the first set was 1, 2, 4, 6. The shuffled set is 6, 2, 4, 1. From a purely numerical view, does 1, 2, 4, 6 look more ordered than 6, 2, 4, 1? Probably not. Just one random-looking sequence changing to another.
I see. So whether it looks ordered or disordered depends entirely on what property, what variable you choose to focus on. Precisely. If you could track everything about those cards, color, number, position, spin of every atom, the idea of order based just on color kind of evaporates. It's just one hyper-complex state changing to another. No obvious direction from order to disorder.
And Rovelli scales this up to the universe,
Yeah.
saying we see entropy increasing because we're only looking at the colors, metaphorically speaking.
Exactly. The universe is vastly more complex. We perceive this large-scale trend towards disorder because we can only grasp a tiny fraction of all the variables. Our view is inherently blurry.
And this links to quantum gravity, right? The really small scale.
Yes. At that fundamental quantum level, things might be just happening, events popping in and out of existence, granular changes, without an obvious overall flow or order.
Yeah.
It only looks smooth and directional when we blur it out when we look at the macroscopic scale.
Because our scale ignores all the incredibly complex details. We average things out.
Right. We perceive order and therefore entropy increasing, and therefore time having a direction, because our interaction with the world is limited and blurry. If we could see the quantum details, the very concepts of order, entropy increase, and maybe time itself might just disappear.
So time, like now, might just be a consequence of our limited human perspective. A sensation arising from how we have to observe the universe, rather than a property of the universe itself. That's really hard to get your head around.
It completely shifts the picture, doesn't it? So if there's no fundamental time, what is the world actually like, and why do we feel it so strongly?
Rovelli's answer to the first part is fascinating. He says a world without objective time isn't static. It's incredibly dynamic, full of events, changes, relationships. Change is the only constant. It's not Plato's unchanging forms.
And science, he argues, actually backs this up. From Newton describing motion to quantum mechanics describing interactions, it's all about how things happen, how events relate, not just about static objects.
The quantum view. The world is events. What we call an object, like a stone, is just a really long-lasting event, a temporary pattern in the quantum fields.
Right. Think of a cloud. It's not a solid thing. It's a process, condensation, wind, evaporation. It's a collection of events.
And us. Humans, we're not static things either. We're biological processes, information flows, changing relationships, complex bundles of events unfolding.
Which brings us back to why we feel time so intensely if it's not fundamental. What are clocks measuring? What is this feeling of forward motion?
People love that Einstein quote, past, present, and future, a stubbornly persistent illusion.
Sounds definitive, right?
But Rovelli offers important context. Einstein wrote that late in life, after a dear friend died. It might have been more a poignant reflection on human experience, loss, and life's fleeting nature, rather than a strict statement about physical time itself.
Ah, okay. That changes the flavor. It's less about physics proving time is unreal, more about its profound impact on us. Exactly. And that leads to Rovelli's core idea. Time, as we experience it, emerges because of us. It arises from our specific interaction with the universe. Just like hats or chairs are concepts that emerge in our scale of observation, not fundamental quantum categories, perhaps time is also something that emerges from our perspective.
Related to the entropy idea again, that entropy increase is relative to the observer.
Yes, like speed needs a reference frame. Maybe entropy increase isn't absolute, but relative to us and the limited variables we can track, we see a past with lower entropy leading to a future with higher entropy because that's the description that makes sense from our blurry viewpoint.
So our human limitations essentially create the appearance of time's flow by making us see order turning into disorder.
And that apparent increase in entropy, that perceived flow, seems to be necessary for things like life, evolution, memory, and consciousness to even be possible.
Okay, but then isn't it an unbelievable coincidence that we, observers who need increasing entropy to exist, happen to be in the part of the universe where entropy looks like it's increasing?
That's where the great analogy from Li Jianlong comes in the Jiannan plums or Inner Mongolian mutton. Do people just happen to like plum wine where plums grow? Or love mutton where sheep are common?
No, it's the other way around. They like it because it's available there.
Exactly. It's not a coincidence we find ourselves in a universe configuration that, from our perspective, shows increasing entropy and allows for time as we know it. We exist because these conditions, from our viewpoint, make life and observers possible. Our existence isn't a fluke within this framework, it's enabled by this framework.
So the deeper we look for time out there, the more we find ourselves looking, well, inwards, at our own perception.
It really seems that way. Which brings us to Rovelli's exploration of human time, that internal feeling of continuity, of being the same person across moments.
The Nagasena and the King's story captures this so well. The king asks for the wise man's name. Nagasena says it's just a label for parts body feelings.
Right, the king pushes back. Is the hair Nagasena? No. The feelings? No. Then Nagasena turns it around. There's a chariot, its wheels, its axle. No, the king admits it's the parts and how they relate, how they function together.
And the conclusion is that a person, like a chariot, isn't a static thing, but a name we give to a collection of relationships and ongoing events.
Which ties directly into our sense of self over time. What connects me now to me yesterday, it's not some unchanging core substance.
Memory seems crucial here. Philosophy and psychology suggest memory integrates experiences from different times into a coherent story of me.
And neuroscience offers clues, too. The brain seems wired to process change and flow, not just static snapshots, like seeing motion directly, not just point A, then point B.
Or hearing a melody, not just isolated notes. The brain integrates over what we perceive as time.
It's like it's making little videos, as the source analogized, not taking still photos. Those memory spheres in Inside Out playing back scenes that captures the feeling. Memory itself contains duration.
So it seems memory, built on a brain structured to perceive processes, helps construct our internal feeling of time's passage and our continuity within it.
Pulling it all together then, Rovelli's big idea, echoed in the sources, is that time isn't some external cosmic metronome. It's something that emerges from the universe when observed by us, creatures with our specific limitations and our entropy-dependent nature.
It's a profound shift. Reality isn't just out there. It's deeply tied to the observer. The search for time leads us back to ourselves.
Exactly. Rovelli mentions that, quote, given to Oedipus. Stop investigating, otherwise you will find yourself.
Maybe that's the ultimate insight here. Trying to pin down time reveals more about our own perception, memory, and maybe the very nature of consciousness.
Definitely a lot to chew on. How does this change how you think about your own past, present, future, knowing they might be constructs arising from your unique place in the cosmos?
It doesn't make them less real to us, but it certainly adds a layer of, well, wonder and mystery to the whole experience. Indeed. Well, thank you for joining us on this deep dive into the perplexing nature of time. We hope it's given you some new ways to think about every passing moment.